So integrated device technology, IDT, has been in the Silicon Valley for more than 30 years, but over the last 10 years or so, I'd say, it's transformed itself into a much more broad-lined company, from one that was focused on memory and programmable logic, for instance. And Eric is with us now to talk about sort of an expansion of your analog mixed signal group and area, which is kind of a new thing for IDT. And we're going to talk about wireless power, which is a very hot thing.
Sure,
Take it
absolutely.
away.
So what we're showing here today are two of our newest products that we announced earlier in March. We've got a wireless power transmitter IC, as well as a wireless power receiver. Now you need both sides of the solution to enable the wireless charging functionality. This is really targeted initially at applications of 5 watts or less. So we're talking about mobile phones being one obvious target segment. So you can see here, this is what we call a single coil. This is a TXA1. You've got a magnet here guiding the coil alignment. So we've got a magnet or a coil here that you can't see. When I put that on there, you can see that the load light turns on, indicating that we're transferring power wirelessly through this connection. Now, this is our receiver IC, but you can see that there are commercial solutions out there. This is a phone that has a supported back cover. When I put that on there, you can see that I enter into wireless charging mode, as shown here.
Yep.
Now, the Qi standard that we support enables interoperability between different devices. You can see here's another phone where it's not as obvious, but this is a back cover that has the coil inside the back cover. If I put that onto the transmitter here, you can see that we enter into wireless charging mode.
Yep.
Now, this is what we bring to the market, is a very high degree of integration in our solution. So you can see that this is an existing solution on the market, a second generation. This entire area here is required to enable the wireless transmitter capability. We've reduced that area by more than 75%. And we have a true single IC solution versus multiple ICs here. Yeah. So cost is a big barrier to adoption for this market or in any new technology. So what we've done is really reduce the system BOM significantly in our solution. Now, this is a case where we're providing more flexibility in terms of placement of your mobile device. So instead of one coil, we have 3 coils. You don't require a magnet to align the coils because you have more spatial freedom. So if I put this phone on here, you can see that we enter into wireless charging mode, and I can move that among this whole space, and you would see that we'd also be able to support that. So applications like automotive, for example, where you don't want to be aligning to precise location, this gives you the spatial freedom using a single transmitter IC to get that type of flexibility.
Interesting. So let's jump back here. How you've reduced board size by about 30%, give or take, if I'm just eyeballing it right. How are you? What are you integrating,
Sure.
and what other design considerations have you taken to shrink that board?
So we've actually reduced it to about 25% of this competing solution size. So we've reduced it by more than 75%. So what we've done is we've integrated MOSFETs, MOSFET drivers, DC regulators, everything that's not a passive component, resistor, capacitor, inductor, has been integrated into this single IC. So it's a very high degree of integration that enables a lot of both digital and analog expertise.
So you save some cost with this approach, but ultimately it seems to me that the coil and just the raw form factor of the end device is kind of your constraint. You don't need to shrink it down to nothing, right? Because this has to sit on it.
Right. Well, actually, on the transmitter side, people are always looking for the smallest devices, the thinnest devices possible, because if you're going to carry around your charger mat while you're traveling to a hotel, for example, you do want it to be as small and as thin as possible. So we enable that from a size perspective as well as a cost perspective. Now, on the receiver side, if you're in a sleeve that you attach to your phone, you have a little bit more freedom in terms of size. But if you're building the coil and the receiver IC into the phone itself, that's where space is very critical. Everyone's looking for every square millimeter of size because you've got so much packed into these smart devices that putting the wireless charger receiver in there as efficiently as possible is really critical.
And you're doing both transmitters and receivers?
We're doing both the transmitter and receiver. So we announced both. This is the receiver. So you can see the area that we require for the receiver. This is the transmitter. So we have both ends of the solution. But because of the WPC compliance, Qi interoperability, we can actually work with any other suppliers receiver or transmitter as well.
So there are other more traditional analog mixed signal companies that are in this space.
Right.
Why would you guys walk into that buzzsaw?
Well, this is new technology. This is exciting technology that's expected to grow significantly over the next couple of years. And it's already started. You can see that there are devices from BlackBerry, Apple, Samsung that already support this type of functionality. So what we did when we started the Analog and Power Group is we wanted to focus on where we could add value. High degree of integration, leveraging both digital and analog. So we didn't start this effort with engineers who had never done this before. We hired the best-in-class people from other companies that have a high amount of experience in this area, and we've integrated them into the company and focused them on these cutting-edge, highly integrated products.
So this is doubtless a very hot area for mobile devices. Come home, throw it on your table side. You don't even have to think about it. Talk to us about some other applications that you guys might be A, designing for, or C, or B, seeing out there that are larger, right? We're driving the Volt around the country.
Right.
You hear a lot about big inductive charging mats.
Sure.
You guys looking at anything like that?
Yeah, so these don't have to be discrete mats. That can be built into tables, charging surfaces in public places, fast food restaurants, hotels, lounges, for example. So this same technology can be implemented in a fixed type of charging area. Now, the WPC right now, they've released a low power spec. It goes up to 5 watts, so it's really geared toward these type of solutions. They're going to be releasing higher power applications, so 125 watts, maybe 25 watts as well. So as the consortium moves forward and releases these new specifications, we'll be there to support it. But right now, Qi is focused on more mobile type of applications.
So this was just announced in March. You have production quantities?
Right, we're sampling now.
You're sampling now, okay.
Right, and we'll be mass production later in Q2.
And don't want to put the cart before the horse, but
sure.
Actually I will. How do you see this design evolving in the next generation?
Well, we're going to be, right now, our receiver solution was geared toward having a lot of other functionality beyond Qi. Back channel communication that allows you to authenticate between both devices if you want to have maybe charge for a fee versus providing it for free. So what we're doing is we're providing we're going to be making a streamlined version of the receiver, again focused on the smaller package, smaller form factors. That's one initiative. We're going to be focusing on automotive segment for an automotive focused transmitter solution, as well as higher power.
And your efficiency on this is pretty good. It's 70%, 75%?
Right, so efficiency is very important. So DC in to regulated 5 volt out on the RX, we're shooting for the mid to high 70s.
All with homegrown component design.
Right, right, and a minimal number of passive components to keep the system BOM low.
Yeah, okay. Well, we'll stay tuned and see how this space expands.
Okay, thank you.
Thank you.